Welcome to the Stormsurf video surf forecast for the week starting Sunday, December 4th. Looking at significant wave heights for the North Pacific Ocean, we see remnants of a gale producing 20-foot seas aimed at the Pacific Northwest, and another portion of a gale fading out, approaching the dateline with 20-foot seas, but other than that, a pretty calm pattern is setting up. We'll start this week's tour looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales. When those gales do form, help direct their track. We're looking for a trough, a dip in the jet. There's sort of a little dip right here over the dateline, but other than that, things do not look particularly inspiring. We have decent winds over Japan at about, 160, 170 knots, but they quickly move out into the Pacific, and you see it actually splits a portion of the jet. The northern branch sort of moves to the north here over the Aleutian Islands, and the southern branch starts falling south. By the time you get to the dateline, the jet is pretty well split, and it continues split the whole way into the Gulf of Alaska, and not till it gets to the eastern Gulf, and you can see the northern branch starts pulling together here, the southern branch joins in, and it consolidates right off of the coast of Oregon, and then wind speeds come back up to something that's respectable, but by then it's too little, too late, and the jet moves inland. So basically, in between the split pattern, one would expect to see high pressure actually circulating this way down at the ocean surface, and that is not good for storm production. Let's look out at the details. So as we put this in motion, we see the split gets even more pronounced come Monday, even though winds build over Japan and a little bit off the U.S. West Coast. But we'll just roll this out and look at this. The jet pushes, the northern branch pushes well up into the Bering Sea come Tuesday, and the opposite is occurring over the dateline. That means high pressure here will only strengthen. We'll just roll this out, and this pretty much sets the tone for the coming week. We see a little bit of something, almost looks like it's trying to get itself back together come Friday, but still there's a big swath of energy being sucked off to the north here. That is on Friday. We'll roll this out, and then finally notice all that motion up to the north at 168 hours out next Sunday finally starts evaporating, and you see some decent energy. What is this? 180 knot winds building off Japan, and again a decent flow pushing into the U.S. West Coast. We'll get out to 180 hours. There's almost some sense that at some point maybe a trough could start digging out here. Hard to say what exactly is causing this. The likely culprit, though, is the inactive phase of the MJO, and we'll get into that in a little bit later in the presentation. But this is not expected. We've had a great run of the jet stream for weeks and weeks now, all driven by the active phase of the MJO, and again, the Kelvin wave generation area is like right down in here. So depending on what's going on here, this influences the jet. Active phase of the MJO feeds the jet in turn feeds storm production, which of course creates surf. But when you get into the inactive phase of the MJO, you get enhanced east trades here. That just sort of cuts off the jet, makes things kind of weak, and the storm track falls apart. Let's go down to the surface. So here we are, surface level pressure, surface level winds. As expected, a little tiny fetch here in the Gulf of Alaska, 30, 35 knot winds producing 20-foot seas. But you see, high pressure is pretty much the name of the game. Another high here off of Japan. And here's what's left of some fetch that came off the Kuril Islands 24 hours ago. And basically, you look at this and just go, there's nothing here that's going to produce surf. And that seems to be kind of the pattern for a while, of course, driven by the weak jet stream pattern. Now we see a cutoff gale trying to organize here on Tuesday. Remember, the jet's pretty strong right in here, so maybe that'll help feed it. And a little bit of a gale tries to get going here off Japan. Remember, the jet's strong here, but right here in the middle where there's the split, look at that. As expected, a 1036 millibar high, kind of like a brick wall right there, just shutting storm production down. We'll roll this out. See, this gale by Wednesday gets going here over the Kuril Islands, but back here, completely landlocked. Our little gale off of Oregon, all the fetch is aimed off to the west, hardly anything at the U.S. West Coast. Can't expect too much. Cutoff low develops on Thursday here north of Hawaii. Now we see a bit of a gale trying to organize here off the Kuril Islands also on Thursday, but just none of it's making eastward progress. Notice, though, that come Friday, the high starts breaking down a little bit. We'll just roll this out and see what happens here. Still, nothing going on. The jet is pretty weak and unorganized, and now we're out 180 hours, and not a whole lot happening. No solid fetch, not even barely any 35 knot winds, just 30 knot winds. You're not going to get any swell of any interest out of that. So the North Pacific appears to be taking a break, but let's verify that. Let's go take a look at the significant wave height charts. So here we are, significant wave heights, a little bit of fetch here as we saw, 20-foot seas in the Gulf, another little patch of 20-foot seas approaching the date line. We'll roll this out. You see the Gulf system just basically dies as it falls southeast. We continue looking. Here's this patch of 18-foot seas associated with a cutoff low there. Not a whole lot going on. A little bit of seas maybe off of the Kuril Islands on Wednesday-ish. Maybe some tiny swell would reach Hawaii, but that's kind of a stretch. Now here's another little area, 32-foot seas come Friday. Again, the same sort of thing. Fetch developing here, but making it nowhere because of the brick wall over the date line of high pressure. Makes a little bit of progress, but not much. And then we just fall into this very lackadaisical pattern a week out. This is Sunday night, a week out. And just really not a whole lot going on. The best suggestion is do your Christmas shopping because things are supposed to wake up a little bit further into the future. And so with that, let's go take a look long term. What's going on with the Madden-Julian oscillation and, of course, La Niña and the interaction of the two of them. As usual, we start looking to see what's going on in the Kelvin wave generation area. That is the area north and south of the equator, 5 degrees north and south from the date line, which would be about right here. Here's the date line. So this is the equatorial Pacific, or you can view it up here. Equatorial Pacific, 170 west. So this is a bit west of Hawaii. Here's New Guinea here, the whole way to New Guinea, 5 degrees north and south. Actual wind speeds you can see over the entire equatorial area, or from the east, a pretty good clip, including in the Kelvin wave generation area. And anomalies, differences in normal for this time of year. Notice there is westerly anomalies developing right on the eastern edge of the Kelvin wave generation area. That is typically indicative of the active phase of the MJO, but then we have pretty strong easterly anomalies back here, and it's the whole Kelvin wave generation area you want to look at. And so the balance is easterly here, mainly driven by La Niña, not so much the MJO, because we've had a good active phase of the MJO in the late October, early November timeframe. That's what was responsible for the epic run of good-sized surf along the U.S. West Coast. And winds were consistently from the east here, but not as strong as they were at other times. So what happens is the active phase of the MJO sort of stomps on the easterly trades that are being enhanced by La Niña. And then when the inactive phase comes in, basically it enhances the easterly wind base state that's already in play by La Niña and sort of doubling down on it. And that's what really starts chopping into the jet stream. And we're seeing that occurring right now. Quick look here at winds, 850 millibar winds, anomalies, that's differences. Normal for this time of year, up at the 850 millibar level is about 4,500 feet in the air. About 1,000 millibars would be down at the surface. And the Kelvin wave generation area, here's the equator, 0 degrees from about 70. Right there's New Guinea. There's the Philippines. So this box right in here, and you see the balance for the past since the 28th of November, east, 29th, 30th. Now here's this little bit of westerly anomalies that we saw in the previous chart, but by and large the balance is easterly. And again, westerly anomalies getting a bit pronounced, but back in here, still easterly. So that just gives you a little bit of more context as what's going on. And then the forecast, again, 850 millibar winds. This is the whole planet stretched out onto one chart. Date line is right here. Kelvin wave generation area basically between these two tick marks, and you can just kind of run down. You see the blues are easterly anomalies, stronger than normal. The yellows are westerly anomalies. The balance since November has been for sure towards easterly anomalies driven by the La Niña base state. But you get these little pulses every now and then of westerly anomalies, nothing too significant. So here we are right now. And again, we saw westerly anomalies, right? There's 180, there's the date line, so about 175. And there's the easterly anomalies back just east of the Philippines. And as we go down for the next week, we see some variation on the same, just not a whole lot of change. We're really thinking the MJO, in terms of surface level winds, because La Niña is in play, it's not a strong La Niña, but it's enough to keep just this constant easterly anomaly flow going, which is not unexpected. So you can't really use the winds so much to monitor the progress of the MJO. And we've traditionally said that west winds in this area are good. East winds in the Kelvin wave generation area are bad because that's what feeds the jet stream. But we're backtracking a little bit on that now and saying there are some other things that happen with the MJO that when the active phase is in play, even though if the wind situation in the Kelvin wave generation area isn't optimal, it still helps feed the jet stream. We'll get into that in a minute. So next we start looking at forecasts for the MJO. The yellows suggest so this is outgoing long wave radiation, that is sunlight reflectivity off the ocean's surface. Yellow suggests more sunlight reflectivity, higher numbers, which therefore means high pressure, which means the inactive phase of the MJO. If you saw blues in this area, and again, it's limited to the Kelvin wave generation area, right about in here. If you saw blues, that means less reflectivity, negative numbers, more cloud cover, and that means the active phase of the MJO. Anyway, you look here, inactive phase in control, but the good news is over the next 2 weeks, if anything, maybe a weak active phase, this per the statistic model. Now the GEFS model, ensemble GFS model, not so encouraging, suggesting the inactive phase is to hold, build to the east, and do pretty much what a standard inactive phase does, and basically stomping on any support for enhancing the jet stream for the next 2 weeks. So that'd get us probably to about the 19th of December. And the active phase, the MJO in this image, is pretty much bottled up in the Indian Ocean and stuck there. Phase diagram charts. So assume you're looking down on the North Pole here. The active phase of the MJO moves from the Indian Ocean to the maritime continent, over the dateline, West Pacific, across the Pacific, now south of the United States, into the Atlantic, over North Africa and back to the Indian Ocean. The active phase just goes round, takes about a month or two to make it the whole way around the planet. 3 weeks on, 3 weeks off in the Pacific Ocean. The heavy dot is where the active phase of the MJO is. If it's inside this circle, that means it's extremely weak. So when the active phase was out here in the 10th, 11th, 12th of November, that was good for storm production, and sure enough, we did have good storms, but now it's crashed into the cone of death and really nothing going on. You look at the GEFS model, it shows the same thing, and the forecast here, this green line says, maybe making some progress in the next 2 weeks towards the maritime continent, but probably not. It's most of those members of the forecast are all inside the circle of death, and not a whole lot is expected there. And then finally, we look at the trusty CFS model, good long-term model used for monitoring El Nino, La Nina, and the MJO. 850 millibar winds, again, up about 4,500 feet. So here we are. Now this chart, past history is down here, and here yellows and oranges are westerly anomalies. But we'll see if we can slide this up just a tick. There you go. So there's the date line running straight up through the picture. So the Kelvin wave generation area is probably about in this area going up. And so you see, as we have been through past couple of months, there really hasn't been any solid westerly anomalies. If anything, our pockets are easterly anomalies. The blues are easterly anomalies. Here's where we are today. There's our little pocket of westerly anomalies. There's our little pocket of easterly anomalies. We'll overlay that. The dotted contour suggests the inactive phase of the MJO, and that's right where we are. And it looked like it is supposed to continue into about Christmas time in the Kelvin wave generation area. And then right after that, right as we get into the new year, the active phase of the MJO is supposed to start building in and continuing into about the end of January, even beyond, and westerly anomalies supposedly developing. We don't believe that, but even if we get neutral anomalies and we get the active phase, there's other components of it that could help feed the jet stream. So this would be our most likely candidate time frame right in here, say, Christmas to end of January. That's when we'll probably get a good pulse of storm activity out over the Pacific Ocean. Now, also note, as the active phase moves east, eventually it will move into the U.S. West Coast, and that could create precipitation. But for now, it looks like maybe a drier pattern, maybe. And then, of course, the inactive phase to follow that. Again, running 3 or 4 weeks in each phase, on and off. So for now, the MJO, not so much a player in the inactive phase. Let's go take a look at La Niña. And we first start by our tour by looking at subsurface ocean temperatures. West Pacific here, East Pacific here. We're going down in depth. These little X's are sensors on anchor lines of the TAO buoy array from the East Pacific to the West Pacific, a couple of degrees north and south of the equator. And you can see warm water, 30-degree isotherm right here in the far West Pacific, typical of La Niña. And as you go east, the warm water, the depth of warm water gets shallower and shallower. That driven by easterly trades causing upwelling, taking deep, colder water and help drawing it up to the surface. And all that you have is this very thin area at the top, 25 meters or so of ocean surface that have sunlight beating on it, trying to warm it, but not nearly as much as over here where the east winds are weaker, far weaker, and all this does is actually take warm water that's at the surface and push it so it all starts piling up here, and you actually get a bubble. The actual ocean is higher in the West Pacific than in the East Pacific. Differences from normal for this time of year, actually we have improvements here. Now, of course, here is our 1 degree above normal temperatures in the West Pacific. In the East Pacific, this was down 2 and 3 and even 4 degrees below normal a couple of months ago. And now, yes, here's the neutral line cutting off roughly on the date line or so, 170 west. But we see basically neutral temperatures, maybe a ½ degree below normal. If this is La Niña, this is not an impressive La Niña at all. And at depth, things are actually getting warmer, maybe suggesting that La Niña is coming to a close. Another version of the same chart showing basically the same thing. 2 contours, that's 1 to 2 degrees below normal, so that's a little bit cooler than what the previous chart showed. But still, notice there's pockets here of warming starting to show up. And only this was down 3 and 4 and even more degrees below normal a couple of months ago. So it too is showing warming by the end of November. And yet more data, upper ocean heat anomalies, West Pacific here, East Pacific here. This is last year, January 2016, the 5th Kelvin wave and the 6th Kelvin wave. That is warm water being driven by strong westerly wind bursts in the Kelvin wave generation area. That's why we like to monitor that Kelvin wave generation area. Not only does it help the jet stream, but it also is a signal for El Nino. Anyway, El Nino wrapped up about March of 2016. Cold water moved in, driven by easterly anomalies. This is the start of La Niña, but here's the real interesting thing. So it was pretty cold, but still not that big of a deal. But look at where we are now in the past 2 or 3 weeks. I mean, these are 0 to ½ degree below normal temperatures, and that means the ocean's getting warmer. Also notice warm water building in the West Pacific, but this suggests that La Niña is moving east, but also fading, moving into its mature phase. And finally, one more piece of data, sea level anomalies here. This is the JSON-2 satellite data. It's hard to see, but here's Mexico, Central America, South America, Australia over here. So Kelvin wave generation area is right in here. El Nino, well, let's try it this way. So this, strip out all the waves, strip out all the tides, strip out chops, strip out any other thing else. And what we're trying to do is measure if there's a difference in sea levels compared to normal. Remember we said warm water was over in the West Pacific, and it actually creates a bump. Warm water expands, making the height of the ocean a little bit higher by 10, 15 centimeters above normal. This is, can't really argue with this. This is accurate to probably half a centimeter or so. This is from the Jason 2 satellite. But over here, what we see is 5 centimeters below normal in this area. That means colder water at depth. That means it contracts, and that means the ocean's just a little bit negative. But you know what? This is a lot better than what it was a month ago when there was minus 10 degree, pretty good pockets of minus 10 centimeter anomalies in here, and even more up to almost 15 at one point. So this again suggests, yes, La Nina is maybe broad, but it's weakening, not very concentrated, and possibly losing energy. So next we go take a look at ocean surface temperature anomalies, differences from normal for this time of year. Okay, so typically La Nina is pretty strong right here along Peru. You get a lot of, I'll call it southeast winds, and then those sort of feed into that easterly trade wind pattern and enhance trades, if anything, during La Nina. That's the hallmark of El Nino. Enhanced trades, more upwelling in this region. And we see, yes, finally some cooler water developing here, and this is all new. This was all warmer. I mean, just to within just a degree or so of the equator. Now cooler water is getting a broader reach in this area, and continuing along the equator out 120 west, so this is south of California, but you want to also notice something here. This is where all the cooling was and has been for months, and notice warming is starting to settle in, and this area is starting to at least make a trend towards returning to normal. It's like La Nina is moving off to the east, moving towards Central America. That is maybe good, maybe bad. Probably suggests La Nina is just working into its mature phase. And then we look at the trend over the past 7 days. Water temperature trends. Blues, things getting cooler, warm. Reds, things getting warmer. We see a general, this is in play the past couple of weeks, kind of a warming trend here along Peru. But right off here, remember we said that expanding pocket of cooler water, you can see it quite plainly here. The trend is water temperatures getting cooler. But then when you get to the Galapagos, things generally warming, and the cooling, there was this strong warm-cool cycle thing going on for months and months. That's starting to significantly break down. We suspect this is sort of like the last hurrah for La Nina right here. And at some point, this is going to break down, and the whole thing is going to start collapsing. Water temperatures off the U.S. West Coast are settling down. High pressure strong off the coast, driving north winds and dropping temperatures. They were up in the San Francisco area, 60, 61 degrees. Now we're down into the 56, 55 degree range, which is about normal for this time of year. And then the overview picture. So here is where the bulk of the cooling was. You can see the blues there. This is where and back here, all this, the yellows, this was all around the Galapagos. Now it's starting to make some inroads. Here's that expanding area of cooler water. But what we're seeing is La Nina is just finally starting to work its way into the East Pacific. Not particularly strong even at that. I mean, this is La Nina, but it's a wimpy La Nina. Not impressive at all. And again, this speaks to what we think is perhaps the building of the active phase of the PDO, or the warm phase of the PDO, a 20 to 30 year cycle. Too early to tell, but considering we'll see where La Nina goes. I mean, we're not even into winter yet, and we're already saying, well, La Nina seems to be kind of fading. If that were the case, then one could implicate the PDO and say the PDO is definitely having an impact and hampering La Nina, which means if we were ever to get another El Nino, if anything, it might help enhance it. So we've talked about the MJO, we've talked about La Nina, but at the end of the day, it's the effect on the atmosphere and the ocean that really makes a difference. This is the Southern Oscillation Index. You can use it to measure basically tell whether La Nina or El Nino is in play. On short term, here's the index, difference in pressure between Darwin, Australia, and Tahiti. Past 4 days, we have negative numbers. Now, that's not indicative of the active phase of the MJO. If it was running for, well, here's another little pocket up here in November. But basically, the balance has been positive. That's suggestive of the inactive phase of the MJO. These numbers are noisy. You use the 30-day average to get a sense of what's going on with the MJO, and the good news here is it was, well, it's actually not great news, but the numbers were down at -5. They rose steadily, suggesting the inactive phase of the MJO pulling into play. But now just recently, numbers are starting to drop a little bit, suggesting the active phase may not be all that strong. And then the 90-day running average here, you can use this to look at La Niña and El Niño. If numbers were negative, it would certainly be El Niño, but we're nowhere there. You can see the numbers have been positive. What's interesting, they too are starting to fall, suggesting that La Niña is probably getting weaker. Now here we graph the 30-day Southern Oscillation Index. You can see the pulses. The negative pulses are the active phase of the MJO. The positive pulses are the inactive phase of the MJO. And then the overall trend here, you can see this was in January 2014, the start of El Nino, and you see the trend line going down and down. El Nino bottomed out here in January 2016, and then we had a major inactive pulse of the MJO and a bunch of follow-on. We never even got any active MJO. It's all inactive, and another one and into July, August, September, October, but then come October, big push of the active phase of the MJO. That's what made all that surf in November. And now we have a little pulse of the inactive phase, but you know what? It's not going anywhere too much. It's going to be interesting to see how this plays out. Maybe we'll get another little pulse of the active phase of the MJO in 2 weeks or so. And here's another way. This measures the strength of the active phase of the MJO. We're talking in 2015. This is with El Nino, and look at this historically. You can see these big pulses of the active phase of the MJO. Took a rest. Another big pulses, not as high. Notice how high these were. And now here we are, in La Nina, MJO getting weaker and weaker. And here's currently, this update's I don't know, maybe a couple times a week. Yeah, now we're in the inactive phase. So we're just looking for other clues of where the MJO is, because we can't use the winds in the Kelvin wave generation area as much as we used to. We can't trust that because of the La Nina base state. It's kind of polluting things. But here, just to take a look, here we're back into 2009 and the El Nino of 2009, 2010. Here's the relative strength of the the active phase of the MJO there. We got some good pulses in 2012, but then these big pulses here, that's what was fueled by El Nino. Also, we can use the ESPI index. That's used instead of measuring differences in pressure between the area north of Darwin, Australia, and Tahiti. This measures absolute precipitation anomalies in the same two broad areas. If the index is positive, that suggests more rainfall in here. If it's negative, less rainfall in here. The current value is minus 0.88. You go, that's negative, that's not good. Yeah, agreed, because it's La Nina. But you know what? It was down at minus 1.9 like a month or 5 or 6 weeks ago, and it's made remarkable recovery here, suggesting that precipitation is at least trying to get a little bit more embedded in this area and suggesting less dryness. That's another indicator that perhaps the La Nina is fading some. And finally, the forecast for the Niño 3.4 region, that's this area between 120 west and 170, the typical area used to measure the presence of La Niña or El Nino. Back in January 2016, warm temperatures, almost 3 degrees above normal. That's 3 degrees centigrade above normal. That's indicative of course, El Nino. Then we had the transition in July towards La Nina. But you know what? Look, our temps only got down to half a degree below normal. And here we are in December. Now this is a forecast, but in November we were only half a degree below normal, and we're working our way through the month of December, forecast to be minus a third of a degree, and then slowly rising from there into the spring and normal by the summer. And if this is the extent of our La Nina, that's not much of a price to pay at all. That also suggests that the warm phase of the PDO is in effect. The warm phase of the PDO tends to favor a El Nino pattern, and that would go on for 15 to 20 to 25 years, suggesting that maybe, and we're coming out of a 15-plus year cycle of the cool phase of the PDO. Maybe we're moving into the warm phase. We'll know in a couple years. But anyway, temperature improvements and the fate of La Niña certainly looks positive at this point in time. And before we wrap this up, let's take one quick look at precipitation. Always interested in snow in this year and rain into California. Here we are, Bay Area here, Southern California down here. We see currently Sunday night, light precipitation in the northern part of California. The interesting part is a little bit of more precipitation to the north into Monday and Tuesday, but then we get into here Wednesday night, precipitation building and coming from the west. That little tiny cutoff low we saw that really didn't have anything in terms of swell production. Well, there appears to be at least the models suggesting precipitation moving down into Big Sur on Wednesday night. Tahoe is right here, Southern Sierra down here. And we see snow building pretty solid over Tahoe on Thursday, that fading out, and then another pulse coming in on Friday, and it's kind of blocked here, but continuing snow, probably higher elevations. Then you get into Saturday, and look, there's a rather intense burst of snow in the Tahoe region on Saturday, and then fading out on Sunday, something to look for. Looking 7 days out at the total amount of precipitation, and we're looking really here for Tahoe. We could look in the Bay Area, and you're looking at maybe an inch to an inch and a quarter of rain, maybe more in the North Bay, into the inch and 3/4. But in Tahoe, let's say the reds here, we're looking at 3 inches maybe, somewhere in that vicinity of precipitation. That could translate into about 3 feet of snow if it was cold enough. Probably not that much. And note, the GFS model always overstates precipitation. This model always overstates it too. But basically, it's suggesting a pretty healthy amount of precipitation in the higher elevations, mainly from, let's say, Yosemite northward, and some for the Bay Area, mainly from Monterey Bay northward there too. So something to look forward to. So to wrap it up, swell-wise, things not looking so good. In an active phase of the MJO is taking control, taking its toll. You know what? Small price to pay. We've had a good run of surf. Use the time, do your Christmas shopping or whatever, get ready for the holidays. The suspicion is we'll move back into the active phase come around Christmas. Things might perk up a little bit. The good bit of news is precipitation looks possible for Tahoe. That'd be good. Bring in some snow, bring in some rain. California needs it. And then we'll see where we go from there. So that's it for this week. Enjoy yourselves. We'll do it again next week. Same time, same channel. Thanks for watching.